Okay, so we're solving system of equations, and we're using the elimination method to solve for x and y. Now, I've been teaching y'all to always look for the x to eliminate, so that's what we're going to go ahead and do to be consistent with what we've been doing in class. So when I look at this, I want to see that these x's get the same coefficient. I have a 2 here and a 3 here. So what I'm going to do is take this coefficient, the 3, and I'm going to multiply each one of these by 3. And then I'm going to look at this and take the 2 coefficient here and multiply it to each one of these terms. So now, when I rewrite this equation, I now have a 6x plus 3y equals 27. And then when I distribute this one, I end up with 6x again minus 2y equals 32. Now, I have an x. Our coefficients for x are now the same. So then we go to the next step, which I've taught y'all how to circle the x's. And I'll look at my x's, 6's here, and see that they're the same sign. So remember, same sign, we're going to subtract. And I turn this into one giant subtraction problem. So now when I'm looking at this, 6 minus 6, that's gone. 3 minus, that was a negative 2. My line kind of went over it, but it's on negative 2. So positive 3 minus negative 2, that's going to give me 5y. And then last we have 27 minus 32, which gives me negative 5. So now I divide both sides by 5, and I get y equals negative 1. Now I told you I'd always take this and go back to the original problem. I'll just always take that first one right there. So I'm going to take 2x plus y equals 9. And remember, we just saw that y equals negative 1. So I'm going to take that value and I'm going to put it right here in place of y. So now I have 2x plus that negative 1 that I just put in there. Now, this is kind of confusing looking. So if I see two different signs like that side by side, that really just means 2x minus 1. And now we're going to add 2 to both sides. Add 1 to both sides. And I have 2x equals 10. And now I divide both sides by 2. And I get x equals 5. And now I write my final answer as 5 comma negative 1. Remember, we write the x and the y. So this is the process we'll use over and over and over again. We'll make sure our x's are the same, and then if they are, we'll eliminate them, and then we'll solve down for y, take the y, plug it back in, and then solve for x, and then write your final answer. And we can always check ourselves by plugging these two things in right here for the x and the y to see if we get 9, and then plugging it in here to see if we get the 16. Alright, so that's the first one. Here's another one. Now, look at your x's. Do they have the same coefficient? They do. I have a 1 and a 1 here. So again, I'm going to circle my x's. Same sign, we subtract. And now we're going to solve this. And the nice thing about this is that we didn't have to do that extra step that we did up here where we multiplied. So now x minus x is gone. Negative 2 minus a positive 3 is a negative 5y. Negative 9 minus 16 is negative 25. So now we'll divide both sides by negative 5. And y equals a positive 5. And now we've got the y value. Now we'll go back up here to the original problem. Sorry, my paper's slipping. Go back to the original problem, and now in place of this y, I'm going to put a positive 5. So I'll just rewrite that. X minus 2y equals negative 9. And remember, we are replacing the y with 5. Now go ahead and multiply this, and we have x minus 10 equals negative 9. Add 10 to both sides. and I'm left with just x equals 1. And so now my solution for this would be 1, 5. And you need to remember each time when we write this as an ordered pair, we do that because that's where these two lines cross on a graph. They touch right there. Alright, the next one. Let's do this one right here. Okay, so looking at my x's, they are not the same. And we are going to have to multiply in order to make them the same. Now, I could just take that negative 21 and put that there, and take the 7 and put it here. But then I'm having to think, and I don't have a calculator sitting here beside me, so I'm really having to think, what's negative 21 times each one of these terms? So instead, I see a 7 here, and I'm thinking, well, 3 times 7 will get me that 21. So that's what I'm going to do. I'm going to rewrite this equation here and multiply each one of these parts times 3. So when I rewrite this, this becomes 21x plus 6y equals 48. And then this already had that 21, so I'm going to just rewrite it right here beside it. And sorry, my hand's kind of all over the place. Alright, so now I have my x's, have that 21 and negative 21. So when I circle this time I'm going to ask myself, we have different signs, so with different signs we add. So 21 plus a negative 21, that's gone. 6 plus negative 6, that does the same thing as this one. This is also gone. So now if this is eliminated and this is eliminated, I'm left with just a 0, and that's it. And then over here I have 48 plus 24, and that is going to be 72. Is this a true or false statement? Does 0 equal 72? And it does not. It is a false statement. That doesn't make any sense mathematically. So therefore that means we are dealing with no solution. What does that mean if we were to graph it? It means that if we were to graph these two lines, they would be parallel lines. They would never touch, meaning there's never a solution, there's never a point that they intersect. Alright, let's look at another one right here. Okay, so again I see we have different x's, and I can take and multiply the second one by 3, and then distribute it to each one. So my original equation, the top one here, doesn't change. It stays 3x minus y equals 2. Then the next equation, I get negative 3x, and then here I get that minus 3y, and then I multiply here and I get 18. That's supposed to be an 18. Okay, so now I'm back to my step of circling, and I have different signs. Different signs add, and now 3 plus a negative 3 is gone. This is a negative 1 plus a negative 3, which gives us negative 4. This is 2 plus 18, which is 20. I'm going to divide both sides by negative 4, and I get y equals negative 5. And remember, we're going to take that back to the original equation, and we have 3x minus y equals 2. And now I can replace y with negative 5. And remember, we just found that right over there. So now, remember, two negatives really make a positive, so that's going to be 3x plus 5 equals 2. How do we get the 5 to the other side? We subtract. That's gone. And now I have 3x equals negative 3. Divide by 3, and we're left with x equals negative 1. So then your final answer would be negative 1, negative 5. And that's your solution for that ordered pair. That looks a lot like one I just did. Hopefully I didn't do it twice. Okay, the last thing I want to show you, I just did one that was no solution, so let's look at that again. We want this to match back up. So this is an 8. I need to get an 8 here, so I'm going to take that second equation and multiply it times 8. And I'm kind of running out of room here, so this top equation, I'm just going to rewrite it because it doesn't change. But my second equation, this becomes negative 8x. This becomes plus 16y. And then at the end, 8 times 5 becomes 40. Alright, circle, and we have different signs, so we're going to add. And 8 plus a negative 8 eliminates. Negative 16 plus a positive 16. Check yourself on that. Negative 16 plus positive 16. There's their opposites, so it also eliminates. So when both of these eliminate, you're left with nothing over here. And then 48 plus 40 is going to give you 88. So again, we get this false statement, because this is not true. So therefore it is no solution. Alright, the last special case that we had was infinitely many solutions. So looking at this one, I've got a 3x here, I need to get a 3x here. So this equation needs to be times 3. So when I rewrite it, I get 3x because 3 times x. 3 times y gives me that plus 3y. 3 times 7 gives me that 21. This one, I didn't need to do anything to it, so I'm just going to rewrite it right here. And I end up with 3x plus 3y equals 21. Okay, now if you can't recognize this, let's keep going. Same sign, we subtract because they're both positive. So 3 minus 3, gone. Positive 3 minus positive 3 is also gone. So on this side here is nothing. What about 21 minus 21? That's also gone. So is this true or false? Yeah, 0 does equal 0. It's true. So that means that there are infinitely many solutions. What it means about the graph is if I graph this line, let's say it looks like this, so I graph this line, then when I go to graph this line as well, it just overlaps on top of that same line. So even though I did 2 different equations, they only graph one line. Well, that makes sense, because when we rewrote them, I ended up with the exact same equation. 3x plus 3y equals 21. 3x plus 3y equals 21. Okay. I hope this helps. This is some additional examples to help get ready for the test on Friday. If you have more questions, come to class with them. And that's it.